So today we're going to be looking at how to solve a system of linear equations differently. If you remember previously we've talked about how to solve them using graphing. And graphing is not technically everyone's favorite choice of things to do. So there's another method we can use. It's called substitution. And you should all know what the word substitute means. It means we're going to take something else and put something different in the exact same spot. Okay. So you should have a graphic organizer in front of you. If you don't, please print one off the website or at least pull it up so that you can follow along. Down the left-hand side, you will see the four steps: solve, substitute, stick, and check. Step 1 is going to be pretty easy today. We're going to work more with step 1 tomorrow. Step 1 says to solve one of the equations for a variable. Well, today you're already going to have that done for you. One of the equations is going to be y equals or x equals. Doesn't matter which one. Doesn't matter if it's x equals or y equals, but you should have one of the two equations that has a variable by itself. You're going to write that equation in spot number 1. So now what happens in spot number 2 is we take the second equation, the x plus 2y equals 11, but we're going to substitute and we're going to take y out of the problem and we're going to put the 3x plus 2 in instead. Everything else in the problem stays the same. So this 1x comes down, the addition sign comes down, the 2 comes down, the y comes out, and the 3x plus 2 goes in, the equal sign comes down, and the 11 comes down. Everything else just comes down. At this point, we have an equation that you should all know how to solve. I'm going to add -4 to each side. I'm going to write over here, and I end up with 7x equaling 7. Divide both sides by 7, and you get x equaling 1. Now, if you remember from when we did the graphing lesson, you remember that the answers to linear systems, they have to be written as ordered pairs, both an x and a y piece. So at this point, we only have the x piece. We need to work on finding out the y, and that's where step 3 comes in. Step 3 says go back to step 1 and take your equation from step 1. My equation from step 1 was y equals 3x plus 2. Take the answer you got and plug it in, almost like you're checking. So 3 times 1 plus 2, y equals 3 plus 2, so y equals 5. So I've now found x and I've now found y. Once you find one of the variables, either x or y, the other one's not too bad to find then. We do need to check. So we check back in the original equations. You have to check back in the original equations. So now we need to go and check. So we got the answer 1, 5. You have to check back in both of your original equations. You do have to check back in both, just like we did with graphing, because sometimes one answer will check in one equation and not the other. So 5 equals 3 times 1 plus 2. 5 equals 3 plus 2. 5 equals 5, and my answer checks in the first equation. Second equation, x plus 2y equals 11. 1 plus 2 times 5 needs to give me 11. 1 plus 10 needs to give me 11. And 11 equals 11. So that's how you do it start to finish. We're going to look at a second one now. It should be on the back of your graphic organizer. In this case, again with step 1, I'm looking for the equation that has a variable all by itself, and that's x equaling -3y plus 5. So for right now, that's all we have for step 1. Now what we do in step 2 is we take our second equation, the one we haven't used yet, y minus 2x equaling negative 3. And everywhere we see x, we're going to take the x out, and we're going to plug in the negative 3y plus 5 instead, giving me a new problem of y plus negative 2 times negative 3y plus 5 equaling negative 3. Everything else stays the same, only the x comes out. Distribute through the parentheses, so 1y plus 6y plus negative 10 needs to equal negative 3. Combine like terms, 7y plus negative 10 needs to equal negative 3. Add 10 to each side. We end up with 7y equaling 7. Divide both sides by 7. We get y equaling 1. One of your answers is not always going to equal 1. That's just how it's working out for these two problems. Now in step 3, what you're going to do is plug back in to step 1, so that x equals negative 3y plus 5. So x equals negative 3 times 1 plus 5, negative 3 plus 5, x equals 2. Final answer, x goes first, 2, 1. And then the last piece is to check it back in the original equations. So the first equation, y plus negative 2x equals negative 3. 1 plus negative 2 times 2 needs to equal negative 3. 1 plus negative 4 needs to equal negative 3. Negative 3 equals negative 3, and that answer checks. Checking it in the second equation, x plus negative 3, x equals. X equals negative 3y plus 5. 2 equals negative 3 times 1 plus 5. 2 equals negative 3 plus 5. 2 equals 2, and my answer checks. Your homework tonight is just some of these practice problems. Go ahead, try them on your own. Use the graphic organizer. I really do think that will help a good bit. So go ahead and try that, and we'll go from there.